Okay, let's dive in. When you hear ozone, chances are you think about that protective layer, way up high in the atmosphere, the one shielding us from UV rays. But today, we're digging into some really eye-opening research. It paints a much more complicated picture of ozone and, frankly, its surprising role in our climate future. Our mission here is to pull out the key insights from this recent study on future ozone changes and, well, their impact on warming. And I think you might be surprised by what they found. It definitely adds a twist.
Yeah, it really does. What's fascinating, or maybe slightly concerning, depending on how you look at it, is that this study projects ozone could become the second biggest contributor to future warming by 2050.
Wow, second.
Second largest, yeah. And that's under a specific scenario called SSP 37.0. Now, this scenario assumes pretty high fossil fuel use continues and we don't implement many new air pollution controls. Under those conditions, the projected warming effect from ozone is around 0.27 watts per square meter. That's measured using effective radiative forcing, ERF.
Okay, 0.27 molar amux. How significant is that, really?
It's pretty significant. To give you some context, it's roughly comparable to maybe half the warming effect we've seen historically from methane. So it's not a small piece of the puzzle at all.
Second largest contributor. That's huge. And honestly, a bit counterintuitive. We tend to think of ozone as either good up high or bad down low. So which one is causing this warming? Or is it both?
It's actually both. And that's where it gets really interesting and quite complex. Historically, yes, the bad ozone, the tropospheric ozone near the ground formed from pollution, that's been the third most important greenhouse gas warmings up so far. But looking ahead, this study shows the increase in warming from ozone is split almost equally between the two types.
Equally?
Pretty much, yeah. About half of that future warming comes from the recovery of the good ozone, the stratospheric layer, as those ozone-depleting substances we banned continue to decrease.
Hold on. So the ozone layer recovering, which we always talk about, is this major environmental win that's actually adding to warming. That feels backwards. How does that work?
It does feel backwards, doesn't it? Yeah. But it's a fascinating bit of atmospheric physics. While stratospheric ozone blocks UV light coming in, it also absorbs infrared radiation heat going out from the Earth. So as that layer gets thicker again, it essentially becomes a slightly better blanket, trapping a bit more heat higher up. This leads to a warming effect down at the surface.
Yeah.
So yeah, the success story of fixing the ozone hole has this secondary climate consequence.
Wow. Okay, so that's half the story. What about the other half of this projected ozone warming? Is that the more familiar bad ozone?
Exactly. The other half is driven by expected increases in that tropospheric ozone, the ground level stuff, and that's fueled by rising emissions of its precursors, things like methane and nitrogen oxides, the pollutants that cook up in sunlight to form ozone smog. The study projects across multiple models about a 12 Dobson unit increase in the total amount of ozone overhead globally by 2050.
Okay, 12 Dobson units, okay.
And about a third of that increase, roughly 4 Dobson units, is happening down here in the troposphere, where it impacts air quality and acts as a greenhouse gas. And this increase isn't uniform. It's particularly strong over places like the Middle East, India, Southeast Asia areas, seeing rapid development and potentially rising emissions under this scenario.
Right. So it's like this double hit then. The good ozone layer is healing, which we want, but that has this slight warming side effect. And at the same time, the bad ozone near the ground is potentially increasing due to pollution, adding more warming. It really underlines the complexity. How do scientists actually pin down these warming effects, especially when they seem so interconnected?
Yeah, it's tricky. They use various metrics, but the gold standard these days is effective radiative forcing, ERF. What's key about ERF is that it doesn't just measure the direct heat trapping by ozone itself. It also includes what are called rapid adjustments in the climate system, things that happen quickly in response to the ozone change.
Like what kind of things?
Well, for instance, the study found that more ozone tends to lead to slightly less cloud cover. Clouds have complex effects, but less cloud can mean more warming. And they also found a pretty robust decrease in surface albedo, meaning the Earth's surface reflects less sunlight and absorbs more heat. ERF captures all these knock-on effects together.
Ah, I see. So it's not just the direct greenhouse effect of the ozone gas, but also how it changes clouds and how much sun the ground absorbs, and it gives a much fuller picture of the total impact.
Exactly. It gives us a more complete and likely more accurate understanding of ozone's overall role in climate change.
Okay, so wrapping our heads around this. For you listening, this deep dive really shows that ozone, often just thought about in terms of sunburn or smog, is actually, yeah, well, a surprisingly major and complicated factor in future climate change. Both the recovery of the good stuff and the pollution creating the bad stuff are driving its warming influence. It kind of reshapes the climate puzzle, doesn't it?
It absolutely does. And if you connect it to the bigger picture, what this research really highlights is how tightly linked air quality policies and climate policies are. Actions we take to cut ozone precursors, methane, NOACs for cleaner air, well, they directly help the climate too. Even while the stratospheric ozone recovery adds its own small warming piece to the puzzle, it really forces us to think holistically about atmospheric chemistry and its sometimes counterintuitive ripple effects.
Absolutely. It certainly challenges easy labels like good and bad when you look at the whole system. So here's something to think about. How does this complex role of ozone change your view of the climate challenge ahead? Definitely something to mull over until our next deep dive.